Welcome to Module 5. This is the Builders module. Module 4 taught you to find risk. This one is about engineering the fixes into the software development lifecycle. So privacy happens by default rather than by heroics. We'll cover writing requirements that engineers can actually implement, the core privacy design patterns, minimization at the schema and API level, consent as an engineered subsystem, the genuinely hard problem of retention and deletion, and how to wire privacy checks into code reviews and CIs. And we'll keep applying everything to our application, StrideWell. The organizing idea of this module is shift left. I'm sure you must have heard of the shift left concept in security. One deliberate privacy touchpoint at every software development lifecycle stage, weighed towards the early ones, which is require and design. That's why requirement and design are highlighted here. At requirement, privacy requirements written along functional ones, which we'll do next. At design, the threat modeling and DPI work from module 4 plus pattern selection. At build, minimized schemas, consent checks, purpose tags. At test, automated tests for data subject request and deletion. At deploy, configuration review, for example, are the default right? Are retention jobs actually scheduled? At operate or monitor, this is where we have drift monitoring and the operational side of write request. The economics justify all of it. A threat caught at design costs a conversation. In production, it costs a migration, a breach notification, and sometimes a fine. Now, privacy work enters the software development lifecycle as requirement, and most privacy requirements are actually terrible. For example, the system shall respect users' privacy. This is untestable, unownable, and it seriously looks decorative. Data retained no longer than necessary. That's basically you quoting the law and not making a decision. Now, let's compare to the good ones. Location stored at no finer than 100-meter resolutions. Raw GPS discarded after route rendering. Now, this is testable at the schema level, and you recognize it as a StrideWell mitigation from exercise 1. Workout history deleted 24 months after inactivity, covering replicas and the ML future store within 30 days. Now, this is a job you can verify. Also, another good one, analytics export restricted to an allow list, enforced by a PR label. This is enforceable in CI. The universal test is could a reviewer or an automated check fail this requirement? If nothing could ever fail it, it isn't a requirement and you need to rewrite it. The privacy patterns literature can be overwhelming. So here's the working taxonomy to use. 4 families. Minimize. This involves collecting less and keep less. where we use on-demand collection instead of hovering upfront, coarse grained values, sampling, and on-device processing. So, for example, raw data never leaves the phone. Separate. Don't let data pools merge. Split identity from behavior per purpose stores, different keys per context, which structurally blocks the lending threat that we discussed from the previous module in Lindo. Abstract. Store the answer, not the data. If the future needs active this week, for example, store that flag, not the time-stamped history that proves it. Hide. Protect what remains. You can use encryption, pseudonymization tokens, access tags, and adding statistical noise, which we are going to discuss in Module 7, Differential Privacy. Design reviews become quicker when you ask, family by family, did we minimize, abstract, or hide? Minimization gets concrete exactly here. The schema and the API are where it lives or dies. 5 practices that we are going to follow. Field audit at design time. Every columns earn its place with a purpose. Might be useful later is how liabilities are born. So we need to ensure that every column has its purpose attached to it. Coarse types. Years of birth instead of full date. Using regions instead of GPS points. Precision is a design choice, so it's very important to choose deliberately. Do you need to know the region where the user is located? Or you need to know the exact GPS location? Purpose and retention as metadata. Purpose tags and return until or TTL columns turn policy into something machine can enforce. This single practice makes Module 2 storage limitation real. Next, API allow list. Responses and vendor exports built from explicit field list, never reflective full object serialization. Oversharing usually ships through a lazy serializer, not a decision. And logs on a diet, hashed ID, truncated IPs, no payloads. Notice the StrideWell line, coercing GPS at right time, and the identifying route threat from exercise 1 dies in the schema. The cheapest possible place to kill it. Module 2 warned that consent is the most demanding lawful basis. Now, here's the engineering demands, and here's the engineering that is required to actually have it built. Again, we go through 4 main capabilities of consent. Number 1, record. Who consented to what? When? Under which policy version? And which UX? That's your accountability evidence. Next, enforce. Processing path checks consent state before acting, and crucially, that means the API and the bar jobs not just hiding a toggle for consent in the UI. Next, propagate. Withdrawal must reach vendor caches and pipeline quickly. When a user withdraws its consent, it must be implemented and propagated immediately. Engineer it as an event, not just a nightly batch that leaves a withdrawal request ignored for hours or at times even weeks. Lastly, prove. Point in time answers. What did this user consent to on the 3rd of March? Because that is precisely the question an auditor or regulator is going to ask. The golden rule on the slide is the one I've seen violated once. Is the one I've seen violated most. The UI collects consent, the backend enforces it. A consent states that no processing path actually checks in theater. Deletion sounds trivial and is anything but. This is where I've seen the most confident teams humbled. The left column on the slide is where deletion goes to die. Backup and long cycles, read replicas and cache that rehydrate deleted rows. The data lake and ML future store nobody's deletion script knows about. Vendor copies in analytics, support and CRM tools, and logs that quietly contain everything. The right column on the other side is what survives contact with production. A TTL first design, expiry decided at right time and enforced by the store itself. Deletion as an event that fans out every subscriber. Crypto erasure, per user encryption keys, destroy the key and the backup go dark. The practical answer to backup problem. Tombstone, so replace and import, don't resurrect the deleted. And a verification job, because a deletion you can't prove happened for accountability purposes, a deletion that didn't exist. The closing line in this module in one sentence is retention that isn't scheduled isn't happening. Now, make the software development lifecycle enforce all of this without you being in the room. Mechanisms, here are some mechanisms that you can use. For example, a schema change gate. Migration touching personal data tables automatically request privacy review, and new columns don't merge without purpose tags. Static checks. Links for raw identifiers in log statements, unapproved SDK import, and new field in vendor export code. This is mechanical to detect, painful to discover in production. Next, policy as code. Retention, residency, and access rules expressed as machine checkable configurations. So violation fails the build rather than surface in an audit. And for human review, arm every reviewer with 3 questions. Does the PR touch new data? Send data to a new destination? Or does it use data for a new purpose? And yes to those answers without a linked privacy review should fail the PR. The division of labor matters. Automate the detectable and reserve humans for the judgment. Checklist without automation gets skipped. Automation without judgment gets gamed. Privacy behaviors regress exactly like futures do, unless they are tested like futures. Here are some tests types that earn their keep. Purpose enforcement at the unit level. For example, a request in a marketing context cannot read service-only fields. Concept false means 403. And the means means the batch job skips the row, remembering that enforcement isn't just the API. Data subject requests end-to-end. Create a rich test user, run the export, and diff the result against the data map, and ensure every store is represented. Deletion verification. Delete a user, then actually scan primary replicas, caches, future store, and log their key. Zero hit after the deletion window, and a default state audit. Snapshot a fresh account and assert it equals to the approved private by default baseline, which in your article 25 by default obligation as a config test. This test also generates something precious, continuous evidence. Evergreen run is an accountability artifact. Let's close the loop on exercise 1 with a StrideWell privacy sprint. Now, every major threat you found is now carrying a pattern family and a shippable fix. Let's go through them individually. The identifying route threats, we use Minimise, where GPS coercing at right time, start end forcing default on. For the add SDK threats, we use separate and minimize. The SDK moves server side behind an allow list, device ID withheld, contextual rather than behavioral adds. For the analytics detecting threats, we use abstract and hide, pseudonymous ID, curated event list, and sensitive future names genericized so cycle tracking usage is no longer legible to the vendor. For the address book disclosure threats, we use hash tokens, mashed server side, and pushed in 24 hours. And for the no TTL failure threat, we use minimize, where we use retain until on every personal table. We also use a monthly verified deletion job, crypto erasure covering backups as discussed in the previous slide. If you notice the shape of each row, as you can see on the page, you have threats, pattern, and testable fix. The pipeline of which we've discussed, find, pattern, ticket, and test, is privacy engineering in one line. 4 key takeaways from this module. Number 1, a privacy requirement that something could fail is worth 100 that nothing can. Write them as acceptance criteria. 2, minimize, separate, abstract, hide. 4 questions that can make design reviews a craft rather than an inspiration. 3, consent and deletion are subsystems. Recorded, enforced, propagated, and proven. And the UI is merely their surface. 4, wire the checks into PR, CIs, and tests so privacy holds when nobody is watching. That is Article 25's by design, cashed out in engineering practice. Next module, we go to the cloud, AWS and Azure specifics, encryption and key management, resident controls, IAM, and the logging pitfalls that catch almost everything. See you in Module 6.